Video solutions for Unit 7 packet, graphing linear equations 47 through 56, February 19th, 2013. So here we're talking about rate of change. We know rate of change is slope. So we know it's the numbers that continually have a pattern of the same thing over and over. We know that slope is the difference of the y's and the difference of the x's. Now, when we're talking about word problems, and we're talking about a ratio, which is what slope is, the ratio of y to x. When we read the word problem, the order in which it's written is also the order in which we write that ratio. So let's look at the first problem. If a car passes mile marker 50 in 2 hours and mile marker 200 in 6 hours, how many miles per hour is the car traveling? Well, let's go ahead and figure out that rate of change. Okay, so first of all, we have mile marker and hours as our label. And then here we have mile marker and hours. Since mile marker comes first, we can now figure out that this would be our y's, this would be our x's, this would be our y's, this would be our x's, because we can graph any two values on a coordinate plane. And we'll do that actually in class tomorrow. So first, let's just figure out our rate of change. Well, we know we're at mile marker 50, and we're going to mile marker 200. So we have to find the difference between them. Okay? If you want to write it then 200 minus 50 and go in this order, that's fine. Okay? Then you got to do the same thing with the x's. So after 6 hours, we started with 2 hours. So what's the difference? So we went from 50, mile marker 50 to 200. That's a difference of 150 miles. Okay? And we started at 2 hours, but ended up at 6 hours. So that's a difference of 4 hours. So right there, this is actually like our slope formula. So we have 150 miles in 4 hours. To make it miles per hour, which means that we need a 1 on the bottom, we simply divide 150 divided by 4. That's how you always get a 1 in the bottom, just divide it. So that goes in there 3 times, that's 12. Bring down the 0. 4 goes into 37 times, that's 28. Okay, and then we can do a decimal here because it is a word problem. So 4 goes into 25 times, and that's even. So we have 37.5. Now we just put it back into our ratio the same way. So 37.5, we know miles was on top, and that 1 hour is on the bottom. So that's how fast he was traveling. Now, not very fast on a highway speed. Maybe he was, traveling on a side road. Okay, remember that for number, I believe it's 47, 48, 49, 50, 52. Okay, 48. The driver sets the cruise control at 55 miles per hour. So that's actually a rate of change. This is what's continuing over and over and over again. After driving for 3 hours, he passes mile marker 650. In 2 more hours, what mile marker will he be passing? Okay, well, we're at 650. Okay, mile marker. Call it MM. He's going 55 miles per hour. Okay, so in 2 more hours, where will he be? Well, this one's a fairly easy problem to solve. I take my 55 miles per hour and I multiply by 2 more hours, and that's going to give me another 110 miles he's going to drive. If he was at 650, and now I add another 110 miles, he should be at mile marker 760. So in that problem, we didn't really need to know rate of change other than the fact that that was his average speed. Okay. 49. Dominic earns $10 per hour for tutoring students and is given $15 for gas every day. Write an equation that represents the situation. So if we think back to some other problems that were kind of like this is like that taxi cab problem, the carpet problem, the cell phone problem, the shuttle bus problem, okay, I think it was the plumber problem. So we know that we're going to have y equals. Now, we know this first part is going to be our rate of change, or our slope, and then we're going to add our constant. So, what's happening over and over? She gets $10 per hour. She gets $15 for gas. So if we think of just one day for this equation, we know she's starting out with 15 bucks. That doesn't change. She doesn't even have to work to get that $15 for gas. But then she gets $10 per hour. So we know she's going to have 10 per something, and we're going to use X as our hours. So now if she worked 3 hours, we could go ahead and figure that out by substituting 3 in for X. She gets $15 in gas that day. So in the end, she's going to get 30 plus 15, which is $45. Okay, if it was a different number of hours she worked, we would substitute a different number for X. So again, the $15 is our constant. That doesn't matter how many hours. So this ends up being our slope, and we could graph that, which we'll do tomorrow. Maria spends $200.50 on groceries in a week, but earned $4,000 total at her last job. Write an equation that represents this. So again, we're thinking of y equals mx plus b, like the last problem. But this is a little different. When Maria spends $200.50, that's going to be a negative. We're taking that away. Okay? She starts with 4,000. So if you think of the placard in our class, remember, the y-intercept is where you start, and the slope is what happens over and over. So we're assuming, okay, that she's going to spend this much every week, but she only made $4,000 total. Maybe it was a contracted job. So in this particular problem, we know she started with $4,000. But now every week, she's going to spend $200.50. So that's our rate of change, because that continues over and over and over again. So 200, and we'll just put 0.5, and we'll use X for weeks. So Y would end up being the amount of money she would have after X number of weeks. If we said that she worked, or that she had 3 weeks worth of groceries, we would put 3 in for the X. She still didn't make any more money. She made $4,000. It doesn't tell us she made any more than that. Oh, that's negative. I'm sorry, and that would be negative. Because remember, spending is a negative. So Y equals, in that case, this would be $601.50. And she started at 4,000. Again, that was a positive. So now if we go ahead and take more positives and subtract the 601.50, we're going to end up with $3,398.50 is what she would still have after 3 weeks, assuming that all she bought was groceries and everything else was paid for. 51. John has a company that charges $4 per pound for gourmet candy plus $7 shipping. Lisa buys 6 pounds of candy. How much will she spend? Well, if we want, we can write an equation. So this is like the one previous where we were babysitting. We know there's an automatic $7 charge. So no matter what she buys, she has to pay $7, or he has to pay $7 for shipping. We know the $4 per pound is our rate. Okay, doesn't matter how many pounds, it's still $4 per pound. So that ends up being our X term. Again, remember, the $4 continues over and over and over again, and the constant is 7 because it doesn't matter how many pounds she buys, it's $7 shipping. Okay, she bought 6 pounds. So we know X was the pound, so we're going to substitute 6 where the X is, and then we're going to solve our equation. So she spends $24 on the candy. She has to spend another 7 for the shipping. So all in all, she's going to spend $31 total. Now, you didn't have to write an equation to do that. You could have just problem solved it by knowing $4 per pound. She buys 6 pounds. So you could have done your 4 times 6 over here. You know it was $24. And then we know she added $7 for shipping. So we didn't have to write an equation. But what the equation does is helps us to figure out a total amount if we change the number of pounds. All right, so now 52 is the same as 47. So again, I'm going to set it up, but I'm not going to finish it. So we know we have our original ratio of 25 to 2, and since 25 comes first, that'll be on top. So she's at 25 mile marker, and that took 2 hours. But now we're going, and we're going to get to 450 mile marker after 5 hours. So basically what we do think of is our slope formula. So this time we're going to go backwards because we have the bigger numbers over here. So 450 minus 25, that's going to be mile markers, and then 5 minus 2 is going to be the number of hours it took to get there. So that's going to be 425 miles in 3 hours. We have to find out how many miles per hour, so we know that's a unit rate. So we divide the top by the bottom to get that unit rate. So that goes in there once. Bring down the 2, excuse me. Goes in there 4 times. That's 0. Bring down the 5. Goes in there once. That's 3. And this time, instead of doing decimals, I'm going to bring that 2 up here. So we know it's 141 2/3, or if we want to round it, 141. We know 2/3 is 0.666 repeating, so we could say 141.7 miles per hour. Now that's a little ridiculous because who goes that fast except for a race car driver, but that's the way it is. 53. Okay, we're going 45 miles per hour. After driving for 2 hours, he passes mile marker 20. In 3 more hours, what mile marker? Well, we know that 45 miles per hour times 3 hours is going to give us 135 more miles. If he was at mile marker 20 when we started our timing, we add that 135 to the 20, and he should be at mile marker 55 after 3 more hours. Okay, 54. I'm going to let you do that. Just remember, it's y equals mx plus b. Okay, remember that the 50 is a one-time payment that day. Doesn't matter how many hours she works. So we're going to call that the constant. That's where she starts. So right off the bat, maybe her dad gives her $50 in the morning. So what represents where we start in our slope-intercept form? We know the 750 per hour ends up being our rate of change because that's the thing that stays the same over and over and over. So where does that go in our slope-intercept form? So if you remember the classwork that we just did a few minutes earlier, you can figure out this one. Okay. Again, Monique spends $400 on groceries in a week but earned $15,000 total at her last job. Write an equation that represents this situation. So again, we know it's going to be in slope-intercept form. Okay, remember this 15,000 is one time. She doesn't make any more money. So again, that will be our constant. So you have to figure out where that goes in the slope-intercept form. The $400 in groceries, you know, is a negative because she spends it. So that's what she's going to do each week. So that ends up being your rate of change, the thing that happens over and over again. So where would that go in your slope-intercept form? Again, look at the previous problems we did in the classwork to figure that out. Okay, Timothy has a company that charges $9 per pound for gourmet candy plus $7 shipping. Janice buys 3 pounds of candy. How much money will she spend? Well, we know that it's $9 per pound. She buys 3 pounds. So what will that equal? And then we're going to add the $7 in shipping. So then you'll get your total. So I'll just briefly outline that for you. All right, and that looks like it's the end. So good luck, and we'll talk more about this tomorrow.